We all know the batteries, and we all know what they are used for. What maybe we don't know is the composition that has a negative electrode, a positive electrode, and electrolyte, and the rest of the components are steel, paper, and plastic. The concern about these batteries is the metals that have the electrodes, such as lead, cadmium, and mercury, and these three metals is what we are going to see today. The characteristics of these metal salts. The color of the lead is a bluish-gray metal. The physical state is a solid, is insoluble in water, is soluble in nitric acid and sulfuric acid, and is insoluble in organic solvents. The color of the cadmium is a silver-white. The physical state is a lustrous metal. It is insoluble in water and is soluble in acids and ammonium nitrate. The color of the mercury is a silver. The physical state of this metal is a liquid. It is very volatile. It is little soluble in water. It is soluble in sulfuric acid, in nitric acid, and is insoluble in hydrochloric acid, and is very soluble in lipids. The transport of the metals, lead, cadmium, and mercury in the batteries depends on where the battery is deposited. Lead can have a high mobility in soil and be carried away in water. Cadmium is expected to partition primarily to soil. This is in 80 and 90%. When released to the environment may leach into the water. In the case of mercury, it is characterized by the gassing of the element from soils and surface waters, followed by atmospheric transport, deposition of mercury back to land and surface waters, and absorption of the compound to soil or sediment particulates. All of the metals can enter the food chains. How can you be exposed to these metals with the batteries? If you've touched a lot of batteries and didn't wash your hands, this is a dermal and oral exposition. If accidentally ingested a battery, this is in the shoulder mostly, this is an oral exposition. You can inhale the mercury because it's very volatile. And you can be exposed in a chronic way if you work with batteries daily. The distribution of the metals in the body is, for the lead, maybe go into blood, bone, and soft tissue. In the case of the cadmium, the majority is going to be located in the liver and the kidneys. For mercury, it can really cross the blood-brain barrier and it can reach all of the organs. The interaction of these metals with the body is, in lead, it can form complexes with a variety of protein and non-protein ligands. Cadmium can bind to anionic groups in proteins and other molecules. The circulation is primarily bound to metallothionein and albumin. Mercury, once absorbed, enters an oxidation reduction cycle through a variety of molecules on different organs and cells. The effect, the disease, and death is what we're going to see later. Lead is not metabolized. As mentioned before, it forms complexes, but it's not biotransformed. Cadmium is not also biotransformed by phase 1 or phase 2 reaction. Cadmium is detoxified to a degree by long-term tissue storage. The biological half-life of cadmium in humans is 10 to 30 years or even more. For mercury, the red blood cells have the ability to rapidly convert mercury vapor to mercuric ion, believed to be converted by the catalyzed compound 1 system. The actual entity for the reduction of mercury to its volatile form is still unclear. The storage of these metals for lead is in the trabecular and cortical bone, but also in the kidneys. The accumulation of cadmium in the brain, intestinal wall, liver, kidneys, placenta, and erythrocytes. In mercury, the kidneys are the organ with the highest mercury bioaccumulation. In low quantity in the brain and fetus, the accumulation increases with the age. Lead, once it's absorbed, is excreted primarily in urine and feces. Sweat, saliva, hair, and nails, and breast milk are the minor routes of excretion. It is excreted very slowly. Cadmium is the metal that is very slowly excreted, urinary and fecal excretion being approximately equal. Half-life in the body in human is more than 26 years, but studies have found that cadmium can be excreted up to 38 years later. Mercury is excreted through urine, feces, and expired air. The feces are a major elimination route for inorganic mercury compounds. Breast milk is another route of excretion. All of the metals affects all levels like cellular, molecular, organisms, population, etc. The effects of the lead, it can be observed at a cellular level, like cellular death. This is an anemia. At the molecular level, we can see loss of the memory. In tissues and organs, it harms the kidneys. at the physiological level causes high blood pressure. At organism level affects growth and population because it can be mortal at high exposures. Cadmium can cause anemia also. It affects the nervous system, harms the kidneys, it causes liver disease, it makes bone frail, mortal in high concentrations, so it reduces the population. In the case of mercury, the chance of tumors of the kind is elevated. In the molecular levels, affects the DNA due to chromosome aberrations, harms the kidneys, causes high blood pressures and heart rate, nervous system is damaged, affects the fetus and may terminate the pregnancy. To determine these effects, we can expose organisms to one of these metals, and we can measure from the blood. This organism is going to be acute or chronic exposure, and with the control and the exposed one, we see the effects that the organisms are presenting. We can also measure the concentration, as mentioned before, and relate the concentration to the effects we are seeing. This is a general perspective. This is how we can determine the effects at different levels of exposition.